Alright, and welcome to Exponential Transformations. Now this is going to be a little bit different than the previous two videos, so let's do a brief little review of how do you graph an exponential function. Well, an exponential function is in the form of a parentheses b to the x minus h, and over here we'll write plus k. Now, the one major switch that you need to be informed of is here the a value is actually the y-intercept. And so I want y'all to think of it as kind of like the vertex. So it's not necessarily the vertex, but it's kind of like the vertex. So with that in mind, let's take a look at the two functions that we're given, and let's see how you would in fact graph these. So in this very first one, we're given the parent function, f of x equals 2 to the power of x. Notice that in front of the parentheses you don't see a number, so it's assumed to be a 1. And then, because there's no number out here, we're always going to assume that this thing starts with what's called a horizontal asymptote. I'll label that as HA at 0. And so this line will get really, really close to the left, and then it'll just kind of shoot up, and then it'll start to increase. Now, the point of focus that you really need to worry about is going to be the y-intercept. So when I see this, when I see g of x is equal to 2 to the x plus 2, this positive 2, or the k value, what it does is it shifts our horizontal asymptote 2 units up. And this actually has the effect, let's go ahead and switch colors here, this has the effect of shifting the y-intercept 2 units up. So I know that now here I have my new horizontal asymptote at positive 2, but the key feature here, the y-intercept, has shifted up by 2 as well. And so this line is very close to the horizontal asymptote, and then as soon as it hits the y-intercept, it just shoots up at the same rate as our original line. Now for this video, your a values or your y-intercepts will always be the same for each function, so that when they shift, all you have to worry about is either shifting it up or down or left or right. So let's describe the transformation. It went up 2 units. And how would we write this? Well, we would write the rule as g of x is equal to, we're not changing the a value at all, so f of, and we didn't change we didn't change our x value. See where we have the x minus h? It was x here, it was x there. So we didn't change inside the parentheses or inside the function. The only thing that we changed was we increased our k value by 2. Alright? And for the purpose of this video, the only things that will ever possibly change are inside the parentheses or the k value. Let's go ahead and take a look at a second example. Okay, now let's go ahead and take a look at example 2. It says the function f of x equals 2, 4 to the x plus 4 is transformed to g of x, which still has a 2 and a 4, which are the same, but now we see an x minus 1, and we go from a 4 to a plus 1. Okay, so let's go ahead and start by graphing this, and I will go ahead and put this f of x in orange. So we have 2 parentheses 4 x plus 4, and let's really break this down. This 2 is telling me that my y-intercept is at 2. This 4 tells me that from the left to the right I am increasing because it is greater than 1. And this plus 4 right here tells me that my horizontal asymptote has actually shifted up 4. My horizontal asymptote has gone up 4. So let's start with our horizontal asymptote. We'll go up 1, 2, 3, 4. And this means that my y-intercept of 2 has also been shifted up 4. So I start at 2 and I go up 1, 2, 3, 4. So our y-intercept is actually at 6. Okay? So as I draw this, it's really close to the horizontal asymptote on the left. And then my function increases through the y-intercept, and we have that gentle curve. In fact, that's how you should describe an exponential function. It is a curve. Okay? Now let's go ahead and talk about our next one. So we really have two things going on here of note. Let's write g of x is equal to 2 to the 4 to the x minus 1 plus 1. Okay, key thing number one here is that our 2 is the y-intercept, and then we have this grouping, so our grouping, or our h value, is x minus 1. We know we always set our grouping equal to 0, so I can add 1, and so x is equal to positive 1. What's that really telling us? That means that we shifted to the right 1 unit. And then this 1 means that my horizontal asymptote has shifted up 1. Okay, so let's kind of talk about how do you graph this. You always start with your horizontal asymptote first. So we're going to go up to positive 1. And my y-intercept was originally 2, but then it has to go up 1 as well. So now we're here at this level. But notice this x minus 1, ultimately our x value is a positive 1. So we go up 1 and then to the right 1. And so you can see that it's really the y-intercept in this case, which is shifted up 1 and to the right 1. And then of course it grows at the same rate. Alright? So what is the focal point here? It's the y-intercept. And whenever our horizontal asymptote shifts up, the y-intercept shifts up. And whenever our h value is shifted left to right, the y-intercept is then shifted left to right. Alright, I hope this helps, and I'll catch y'all in our next video. Oh, I'm sorry, let's describe the transformation. So we went to the right 1, and we went, notice that we actually went from a height of 4 down to a height of 3, so we actually shifted down 3. And then what would be our rule? Well, we'd say g of x is equal to f of x. Notice, because we went to the right 1, we put the opposite, x minus 1, and then we went down 3, minus 3. Alright, I hope this helps, and I'll catch y'all in our next video.